Welcome all to next class of gravitation, in which basically we'll discuss about gravitational field due to long cylindrical shell or infinitely long cylindrical shell. So just consider an infinitely long cylinder, and our aim is to find out what about the value of gravitational potential, gravitational field at a point P over here, which is at a distance x from the center or x from this axial line. So in the in this situation, we are going to find out the value of gravitational field at point P in three different cases. One thing is when the point is inside, when the point is on the surface, and when the point is outside. So first of all, let's see a condition, that is, we can write it as case 1. If the value of x is less than r, where r represents the radius of cylinder, and if x is the distance from the axis, and if it is less than r, that means we are going to find out the value of gravitational field inside the cylinder. So when it is inside, we know that if it is at the center, let's say the value of x is equal to 0, that means if you are considering a point inside, so each and every point over here is going to exert force in, or the cylindrical surface is going to exert gravitational field in each and every possible direction, so that net gravitational field is equal to 0. Same as like at any point, the value of net gravitational field inside the cylinder is equal to 0, same as like a solid, same as like a hollow sphere. So inside, the value of gravitational field is going to be 0. Now we are going to find out what about the value of gravitational field outside. That means if I am just considering a point somewhere over here, which is at a distance x from the center. And if you want to find out what about the value of gravitational field outside, so we can just assume that the total mass of this one is concentrated just like a wire at the axial line. That means due to symmetry, we can say that its total mass is concentrated on this line. So in the initial classes or in the previous classes, we just discussed about what about the value of like a gravitational field due to an infinitely long wire. So if it is an infinitely long wire, we discussed that if you are considering a point P which is at a distance let's say x from the center or x from this line, then the equation for gravitational field over here, G is equal to nothing but 2g lambda divided by x. So we are going to use the same equation over here, but as it is in cylindrical shape, we need to find out if you are considering the cylinder or hollow cylinder as same as like a wire element. So what about the value of its linear mass density? So we know that its linear mass density lambda is nothing but mass of that cylinder or mass of that wire divided by its length. So we can just find out what about the mass of a cylinder which is having a length L. So in this type of question, they will give the value of sigma. Sigma is nothing but its mass per unit area, or it is also known as nothing but areal density. So this is nothing but mass divided by area. So if you know the value of mass divided by area, so we can find out the value of mass is equal to sigma into area. Now let's see how to find out the value of this area. If you know the value of this like sigma into A, area can be written as area of cylinder. We can write that is equal to 2 pi r into its circumference into length divided by L. So I'll get the value of its linear mass density in terms of areal mass density, that is sigma into 2 pi into r. So we can find out what about the value of gravitational field outside. So that is nothing but 2g lambda divided by x. So you can write 2 into g into lambda in terms of sigma. Sigma into 2 pi r divided by distance, which we can take it as nothing but x. So we can write this is equal to 2 into 2, that is 4 into g into sigma pi divided by x into r by x is a value of gravitational field outside. So we can just consider the second case, let's say case 2, which is if the value of x is greater than that of r, means as we discussed outside, then we can use this equation g is equal to 4 into g into sigma pi into r divided by x. So we can say that outside this g is inversely proportional to x. Same as like that, if you want to find out on the surface, let's say case 3, when the value of this x is equal to r, when it is on the surface. So we can write the value of g is equal to 4 into g into sigma into pi into r. The difference is over here the value of x is going to be nothing but r. So this r and this r get cancelled. So we'll get as it is 4g sigma pi is a value of gravitational field on the surface. And on outside surface, we already wrote the equation. So once again, just remember how we'll calculate the value of gravitational field due to a hollow cylinder. So due to a hollow cylinder, if you want to find out the value of gravitational field which is on the or which is inside, so at this particular point this will be equal to 0, and inside any point the value of gravitational field will be equal to 0. So first point is inside the value of gravitational field is equal to 0. Second point, if it is on the surface, then the value of gravitational field is equal to 4g sigma by pi, where sigma is nothing but its areal density or mass per unit area of cylinder. And third point, when it is outside, so we can write that is 4g sigma pi divided by r by x. So if you want to, sometimes in question they may ask to find out a graph which is showing the relation between gravitational field with respect to distance. So we can draw the graph something like this. From center to surface, the value of gravitational field is equal to 0. And on the surface, gravitational field is having a maximum value that is equal to 4g sigma by pi. And after that it is inversely proportional to x, and at infinity it's going to be equal to 0. So this is the variation of gravitational field g with respect to distance x from the center. Hope so that you understood whatever the things we discussed in this class. If you are having any doubt, please free to ask. Thank you.